All right, so we want to talk about carrying out significance tests. And the first, well, we have phantom. So I know we had panic and it was like PANIC. We got three extra letters now with phantoms. So it is a little bit more tricky, but this is what you hear a lot of in papers and published places. And so we want to make sure that we understand these and can do them ourselves. Okay. So the first thing is you need to identify your parameter, and mu is either a population mean or rho is a population proportion. Okay. And so you define your parameter and your hypotheses. Your null is always mu equals some number or rho equals some number. And your alternative is your mu might be not equal to that number. This same number is the same. Okay, this is the claim number, and we're saying it's equal to the claim or it's not equal to the claim. This would be two tail, or you would say rho is less than or um, greater than some proportion. This would be one tail. Okay, our assumptions are yet again random, independent, and normal. Okay, and those are the same ones we've been using: random, simple random sample, independent or 10%, normal based on, for these guys, normal population or central limit theorem, or my distribution is relatively symmetric, no strong skewness or outliers. And here it's large counts, NP and NQ both at least 10. All right. Once you have that, then you can name your test, and you can name your test by writing down the formula for the test statistic, or you can name the test by just saying it's eventually we'll have one or two sample or proportion. Okay. So sample is for means. Okay. One or two sample. Really, it'll be X bars. This will be when you have a P hat. And then you have up here Z or T. Down here, it's always Z test. Okay. And so we'll talk through about how to know which ones you're doing. We haven't even gotten to the two samples yet, but we'll get there. Okay. So pretty much it'll be a one sample Z test, a one sample T test, or a one prop Z test. Okay. And then you need your test statistic. Okay. We're used to getting a Z score where you do X bar minus your null hypothesis mean divided by sigma over your square root of n, because that's your standard deviation. And then based on that, the probability that I would get a X bar or a Z greater than Z is my p-value. Probability that a sample is more unusual than mine is your p-value. Okay, you make a decision about the null. Oh, I left it out way back out here. When you're talking about your parameter, really anywhere up here, if you want to put it in with your A, you have your assumptions and your alpha. Okay, your alpha, you set that equal to 0.05. Okay, so here, if your P is greater than alpha, then you fail to reject. And when that happens, you state that insufficient evidence in favor of the alternative. If your P is less than alpha, then you reject the null and you say that there is sufficient evidence to conclude, okay, evidence suggests the alternative. Okay, that's your process that you go through every single time, and phantoms will guide you through it. Okay, your parameter, your hypotheses, your assumptions, naming the test, finding your test statistic, obtaining a p-value, making a decision about the null, and your conclusion about the alternative, and then you're done. I know it sounds like a lot. Let's take a quick look at the book here. Okay, the book breaks it down into a few steps. They talk about hypothesis, conditions, calculations, so they boil things together, and then interpretation. Okay. And this is all sort of broken down in phantoms. You could remember these four steps if you want. Okay. And you can see they talk about a 1 versus 2 tail test, but here's one where they work through it. Okay. Medical director examines medical records looking at the blood pressure. Okay. The mean is 128, standard deviation is 15, and he's wondering, Are my employees stressed out? Is this evidence that the mean blood pressure for all companies' younger male executives is different than the national average, right? National average is 128. I took a sample of 72 executives and they had a 129.93. Do they have high blood pressure? And so the hypothesis, mu is 128. Alternative, mu is not 128. Okay. And notice, is this, see how it says is different? Okay. If you think about different, it could mean either direction. That's why they went with not equal. And you need to be reading carefully to see if it's a not equal or if it's a less than or greater than. So they talk about their hypotheses. Notice they define mu, okay? And your null and alternative are always in terms of mu. That's the claim. And it's either equal to the claim or not equal to the claim. And then the conditions, they talk about simple random sample. We do not know what the distribution was. Large sample size guarantees the sampling distribution will approximately normal by the central limit theorem. And then independence, there's got to be at least 720 middle-aged male executives in the company. And we need to assume that. We don't know how many executives there are. So we'll just assume it so that we can go forward. And then the test statistic, there's my z, is x bar minus mu, 15 over square root of n. All right. And we get 1.09. Okay. And then my p-value is it's doubled because it's on both sides. Okay. So the probability of both of them combined is 2.758. If you just did the probability of one of them, you would get about 14% beyond this or 14% below that. And then you double it to get the almost 28% for your p-value. And then you make a conclusion. 27% of the time, a simple random sample of size 72 would have a mean blood pressure at least as far from 128 as what we observed, 129.93. It's therefore not good evidence. It's insufficient evidence. So notice we fail to reject the fact that they differ. Okay, so that's the process that we're going to be going through. You can use phantoms or you can use these 4 steps that the textbook suggests, but just make sure you're checking off all the boxes. All right, we'll do plenty more of these. Have a great day.